4.6 number 17. Water is flowing at a rate of 50 meters cubed per minute. From a concrete conical reservoir vertex, so it's a cone vertex down. It's flowing. Okay, so our change in volume is going to be negative. We've got a cone, looks like this. Base radius is 45 meters. And our height is 6 meters. Okay, not exactly drawn to scale. How fast is the water level falling when the water is 5 meters deep? Alright, so call that 5 meters. And we're looking for how fast is the water level falling. So we're looking for dH dt equals question mark. Alright, so we have our sketch. We're dealing with volume of a cone, so the volume of a cone is 1/3 pi r squared h. We have dV dt, but we have too many. We have two variables, so we're gonna have. We don't know what dr dt is. So as it is, we would need dr dt if we're going to find dH dt. If you use that equation, so we need to eliminate a variable. We're looking for dH dt, so we're going to have to eliminate r. So how are they related? Well, if you set up similar triangles like this, sorry, mail carrier just walked by. Dog had to say hello. Okay, so similar triangles. If I know the height is 6, the radius is 45. Radius is r, height is h. So those are two similar triangles. So we can do 45 is to 6 as r is to h. Cross multiply, 6r equals 45h. And we're going to solve for r here because we need to write r in terms of h. So r equals 45 sixths h. That's the 3 goes in there, 15 over 2. So 15 halves h is what r is. Alright, so our new and improved volume equation is going to be pi over 3 r squared, but r is 15 halves h squared times another h. So volume is 225 over 4 h cubed. So volume is 225 pi over 12. And I guess 3 goes into that. Let's see, 75 times. Alright, h cubed. Alright, so we're now ready to find our derivative with respect to time. So dV dt equals 225 pi over 4h squared times dH dt. Our h is given to be 5. Now we can substitute our 5 in. Initially that's a variable, but now at that point our h is 5 and our dH dt is what we're looking for. Our dV dt is negative 50. That's a given. Alright, so divide by 25. That gives you -2. So multiply by the reciprocal, so it would be -8 over 225 pi is your dH/dt. Our units, our height is dropping, we're in meters, so it would be meters per second. Meters per minute, sorry. Alright, so that's part A. How fast is the water level falling? And part B says how fast is the radius of the water's surface changing at that moment. Okay, so this isn't as much work. We've done some of the work, quite a bit of the work already. We know that this is our equation right here. And when we solve for dH/dt, we needed h in it. If we're going to solve for dR/dt now, we need r in it. So in this equation right here, we're going to solve for h. So h would be 2/15 r. So now our new and improved equation here, the volume is pi over 3 r squared times h, which now we know is 2/15 r. So we have volume equals 2 pi over 45 r cubed. Now we can find our derivative with respect to time. 6 pi over 45, I guess I could have simplified that. So it would be 2 pi over 15. Our r, well, we don't know r, but we did know h. We knew that it's 5. Our height is 5. So we can find r by plugging 5 in for h, and that would be 75 over 2. So dV dt equals 2 pi over 15 times, what do I say, 75 over 2 squared dr dt, and we know that dV dt is still -50. So -50 equals 2 pi over 15 times whatever that big number is, dr dt. I think I'm going decimal. That divided by that. Just on our calculator. I'll pause the video and then tell you. Could help myself, I had to leave it in terms of pi. So divide, multiply, and so on. dr dt is -4 over 15 pi. So it makes sense that we get a negative because the water is draining out of the tank. So my radius is getting smaller and smaller. So our dr dt should be negative.